Hello everyone, I am Madan Kumar. Now I'm going to present my final project for the video game development. So my course title: Learn to build your own video game with Unity and Kinect. So the platform I used was MIT OpenCourseWare and prepared by myself. Let's get into it. So the course introduction. So 9-day intensive hands-on workshop that I was work and focused on using Unity, Game Engine and Microsoft Kinect, open to all learners and no programming language or design background required for that course. So the objectives are build educational games, learn practical skills in game design, and then encourage creativity, teamwork and problem solving. So the course instructors and overview. Instructors like Kyle Kane and Andrew Ringler, Abhinav Gandhi and Mark Rablick. And focus areas like Unity game development, human-computer interaction, and gesture control using Kinect, using user interface and game mechanics. Learning methods like lectures, lab sessions, and group projects. So the curriculum and schedule overview. So there are 9 sessions and 3 hours each. And phases like introduction to GitHub, Unity basics, roll a ball tutorial, and Kinect setup, sensor data handling, and gesture control. Mini project followed by major team project. Ends with a long project exhibition and a peer review and feedback. So Unity Engine fundamentals. Developed a roll a ball game as the first project, and the concepts that I covered was scene setup, creating environments like my terrain and everything, and C# scripting, moving the ball, collecting objects like, and physics applying for forces collisions like that, and UI elements, score display instructions, and hands-on practical encouraged peer problem solving. So Kinect interaction. So introduction to Microsoft Kinect V2 sensor. Skills that I was learned like capturing a full body gestures, mapping a player, and movements to in game objects, real-time motion data streaming into Unity. So example like controlling roller ball using body motion instead of keyboard. And then the course instruction introduced Microsoft Kinect version 2 sensor as a tool to enable body-derived game control. Students learned the fundamentals of setting up the Kinect and hardware and configuring the Kinect SDK within Unity. Though this, they accessed the real-time body tracking data, including skillet joint positions and depth information. This data allowed players to control game objects using physical gestures instead of keyboard or mouse input. For example, the adapted rollerball game, the ball's movement was directly linked to the tilt and learned to the player's body. This process involved capturing data streaming for Kinect and interrupting movements patterns and translating them into meaningful in-game actions. The experience highlighted the complexities of gesture-based interaction, such as handling noisy sensors, data and ensuring responsive, intuitive control schemes. Then collaboration and design. Team formation for project work. Used GitHub for version control and commits, branches, pull requests like that. Activities like brainstorming game ideas, asset creation, and 3D models textures, coding debugging together, So the result improved technical communication and teamwork. So the short project that I was done, small experimental games developed quickly to test concepts like antisocial game about navigating social anxiety using body movements and body paint, use gestures to create virtual art, and Godzilla control a giant by monster by flailing arms, and a cube constructor assemble 3D structure via gesture inputs, and then outcome freedom to explore creative and technical ideas. And then the long project and exhibition. Final 4-day team project. Tasks like original game design using Unity and Kinect, team coding, assets developed and debugging. So the presentation to classmates and invited audience, peer voting to select the most innovative and fun games. So the long project constituted the most significant challenge of the workshop. Over the course 4 days, teams designed and developed original Kinect powered games from scratch. This phase demanded integration of all prior lessons. Unity programming, Kinect gestures control, UI UX design, and collaborative development. Projects with tailored to be both functional and entertaining. Showcasing creativity and technical skills, the workshop concluded with a public exhibition with each team demonstrated their games to an audience uh, of classmates, instructor, and invited guests. Peer voted on the most impressive projects based on creativity and playability and technical execution. This exhibition simulated a real-world product path and emphasized to importance of presentation and user engagement. And then learning experience and reflections. So skills that are acquired by me: Unity and C# proficiency, and then Kinect SDK setup and usage, and then GitHub workflow for collaborative coding, basic 3D modeling and UI design, and reflections, confidence in rapid prototyping, problem solving via teamwork, creativity in combining tech and storytelling. And then the course delivered uh, a rich and rewarding learning experience, and then blending technical skills, building with creative and innovation. So the participants emerged with practical proficiency in Unity game development and C#, as well as a solid understanding of Kinect sensor integration. Beyond technical skills, the workshop enhanced problem solving abilities and adaptability and confidence in handling new software and hardware tools. The use of GitHub familiarized students with vision control practice critical to professional software development. And professional reflections from the course highlight the satisfaction on building functional games, overcoming challenges in real-time debugging, and then uh, learning to collaborative effective under time constraints. The balance of structure and freedom allowed students to take ownership of their learning journey. And then conclusion and takeaways: strong foundation in interactive video game development, gestures recognition and real-time input processing, and then relevance to my experiences, educational game design, and then human computer interaction design and research, and then future Unity and Kinect projects. So the most importance of this activity is interactive design, and then peer feedback and loops. Then thank you.